Hello, everyone, and welcome to our next webinar on motion design using Unreal Engine and Cinema 4D. My name's Darrell Robert, and today I have the pleasure of presenting with my good buddy Andy. We're going to be spending the time in this webinar to give you a high-level overview of a few of the concepts that we use to generate this sports promo that you see playing in the background. So we're going to look at look development and how we can use the GPU Lightmass as well as dynamic lights to get the scene kind of looking like this. I'll touch on materials. Andy's going to jump in and show you the Cinema 4D workflow and how we can use Datasmith to get all of that animation data brought in seamlessly into Unreal Engine. And we'll finish off by checking out the control rig for a couple of interesting things that we did for these characters. So let's go ahead and hop into the engine and get started. All right, so the first thing that we're going to want to do is enable some plugins and set some project-specific settings. So let's go ahead and jump into the Plugins Manager. And in the Plugins Manager, the first plugin that we're going to load is Datasmith. So this is going to allow us to bring in that Cinema 4D file. And you can see I already have that enabled in my project. The next plugin that we used for this project was Control Rig. This is a really cool set of tools for rigging characters, and I'll show you a bit of that more toward the end of the presentation. And the final plugin that we used is GPU Lightmass. So this is going to allow us to use the GPU to do all our light baking operations extremely quickly and interactively. So after those plugins are loaded, the next thing that I want to draw your attention to are a few project-specific settings. So in our projects, we are using that GPU Lightmass, and there's a couple things you want to enable with textures with regards to that. So you're going to search out for texture, and you can see that I've got texture streaming turned on, and it's really important that you enable virtual textures and the virtual texture light maps. This is going to allow that GPU Lightmass to give us interactive feedback as we're working with it, which is really pretty cool. So another thing that we have enabled is ray tracing. This is necessary for the GPU Lightmass to work, as well as a lot of the look that we have in this scene was using ray traced effects. So ray traced reflections, ray traced ambient occlusion, as well as ray traced shadows and things like that. So the final thing that you're going to want to do is just make sure you go down to your platforms under Windows and make sure that the default RHI is set to DirectX 12. This is going to be necessary for the ray tracing to actually be enabled and turned on. So those are the few project-specific settings that we had done. Let's go ahead and talk about how we lit the scene. Here we have the robot and the stadium imported into a fresh level to begin our look development work. And we're going to be lighting this scene using a combination of dynamic lights for the movable objects and baked lighting for the static and stationary objects and lights that are in the scene using the GPU Light Baker. So right now the scene is set to unlit. If we jump over to a lit mode, you can see that it's extremely dark. And the reason that it's so dark is there are no lights currently in this level, but there are some emissive materials that were brought in through the Cinema 4D import. And we can use that emissiveness to drive illumination in the GPU Light Baker. So let's check out how to do that by going to Build, bringing up GPU Lightmass, and modifying a few of these attributes. So the first thing that we want to do is change the mode from full bake to bake what you see. Essentially, bake what's currently visible in the viewport. We're going to switch the GI samples up a bit to 1024. This is using a Russian roulette algorithm, so just increase that until you have noise-free results. And I'm going to overdrive the shadow samples a little bit to increase the visual fidelity as well as the irradiance cache. These are very conservative numbers I'm using just to keep the demo moving quickly, so feel free to play around with this, but they can go much, much higher. So we'll start the light baking process by clicking the green button, and as soon as we do that, you can see that emissive material starts to add illumination into the scene, and this is better visualized by switching our lighting mode to lighting only, and you can really start to see that information coming in. Now currently the GPU is driving the real-time viewport as well as calculating those maps. We turn off the real-time viewport, you can see it speeds it up drastically, so it gets much, much faster. Once we've reached 100%, we've basically calculated out the lighting information for the current view, so we can save and stop building. When we do the save and stop build, we're going to denoise the textures and save them onto each static mesh. Now, this starts to give us a pretty good interactive experience. We start to get a sense of what that light baking looks like. And it's pretty splotchy. The reason it is this way is because it's still a very low resolution baking process. Each individual static mesh has a texture map associated with it, and the default values are pretty low. So to visualize that, we can go to Optimize View Mode, and we can turn on the Lightmap Density. So this is going to give us a grid on every individual static mesh that lets us see how big that Lightmap texture is. And it's also color coded. Now you don't really see the color coding because they're all pretty low resolution. So let's just grab all the static meshes and go down to the details panel, and let's increase the resolution from 64 to 256. Now, as soon as I do that, the grid is obviously much tighter, as well as the color coding starts to show up. So blue is low resolution, green is ideal, and red would be considered high resolution. And red might be bad in a gaming scenario, but for a lot of media entertainment or enterprise workflows, going to red on your Lightmap resolutions will not be an issue. You're on a big hardware, you're not doing like game open world stuff, so don't be afraid of red for certain situations if you have the hardware to handle it. So I'm going to actually overdrive that basketball hoops texture map to 1024 so that it's red, and then we're going to just increase the resolution on a few of these so that when we calculate out the light baking one more time, you're going to get a sense of what this improvement happens with the visual fidelity for each one of these guys. So, we'll just kind of overdrive a few of those. That looks pretty good. So we'll switch this back to show lighting only, and we'll kick this back off. So you can see, obviously, it's sampling much finer on that basketball hoop. The progress bars are smaller, again, to give us a nice visual representation as to what's going on. And as I start to move my scene around here, you can see that based on what I'm currently viewing, it starts to paint in and fill in that light map information, and the progress bars just kind of move along and give you this nice visual representation as to what's happening. And of course, at any time, if I want to further accelerate this, I can turn off the real-time viewport and let it just kind of resolve in on just this single frame using all the GPU horsepower to do that. Once it reaches 100%, of course, I can stop and save the build, and it's going to go through and encode the textures, run the denoiser, and that basketball hoop is going to look, really pretty awesome at this point. Now, of course, what we've done is we've only calculated the information for the view. So if we look behind us, very little of the light map information's been stored back there, but that kind of gives you an understanding of what's going on with that. So the next thing that we want to do is let's just go ahead and switch this to do a full bake. Let's get everything baked into the scene here, and we'll start that build. So it goes off, and again, we can turn off the real-time viewport just to throw all the resources at it, and it's going to kind of, plow through this really quickly now. And the thing that's kind of nice about the full bake is it's going to automatically encode the textures, run the denoiser, and save them all in one click. So with that done, we've now essentially got a preliminary light bake. I mean, we obviously haven't increased the resolution on all the maps, but you get a sense of how that light's moving through the scene to give us this overall global illumination based on just the irradiance information that's in there. Now, one thing that's kind of interesting to think about is not only are we baking out the lighting information and saving it in the form of texture maps on every static mesh, but we're also calculating how that lighting information is moving through the volume. And it's generating a volumetric light map. So you can go to visualize volumetric light map to get a sense of what that's done. So all of these spherical harmonic probes are capturing that global illumination or indirect illumination model that will then be used to help illuminate objects that are set to movable. So things that aren't baked are actually going to use this volumetric light probe to get that indirect lighting model added onto it so that they look really awesome. And this is one of the things that's so cool about Unreal, right? And you can see that where they are close to bright objects, the spheres are obviously brighter, and then there's directionality associated with it also. So if we kind of come over here and look underneath this overhang, obviously the light's flooding in from the side and hitting the side of that spherical capture or that spherical probe. And then of course you come out here and it's it's kind of picking up all that lighting information that's moving through that volume, and that's again going to be used to help illuminate things like the animated character or any objects that you have animated in the scene. Now it's also worth mentioning that volumetric light map, you have control over how dense it is. So in the final project, I overdrove that a fair bit, like down to a value of 50. But for the next light map bake we'll just put that to a cell size of 100. So it'll be twice as dense as what it currently is. So let's disable the display of that, and let's just look at the lit display. So here we are, and you can see that obviously it's not well lit because we didn't add any lights to the scene, but just the emissive objects were able to add in a little bit of lighting into the scene and sort of give you an understanding of hopefully how that GPU light baking works. So the next thing that we want to do is we want to go ahead and we want to start to add in more lights into the scene and get this looking a bit more like the finished result. And, ultimately the way we lit it was with a big area light underneath the scoreboard and like 100 or over 100 spotlights tied into each one of these downlights. So I'm going to walk you through what lighting files in Unreal is like. Let's check it out. All right, so let's go ahead and just pull back a little bit and jump up to Windows, place actors to start getting to the lights, and we'll go to the lights tab. And I'm going to drop in a rectangle light to kind of walk you through the basics of what lighting in Unreal is all about. So we'll jump to the details for this light, and let's just give it a little more intensity. And you'll notice that there's a sphere wrapped around that light. That's the attenuation radius, and that has to encompass geometry for it to get illuminated by that light. So we're just going to increase that attenuation radius so that it covers the whole stadium. And then we'll just rotate this light so that it's sort of positioned and facing down off that scoreboard. And I can just kind of move this guy up a little bit. That looks pretty good. And then just we'll zero that stuff out. So that looks good. So the next thing we're going to do is just give it a little more size by adjusting the source width as well as the source height so that it kind of is this nice big area light underneath the scoreboard, which looks great. So the next thing we want to talk about is mobility and what mobility does inside of Unreal for lights and for objects. So it's a kind of a key concept. So a couple of them are easy to understand, static and movable. So static lights they're fixed. They're 100% baked lighting. So they're part of the Lightmass calculation. They add to the indirect illumination model. And once they've been baked, they're essentially free to calculate. So they work only with non-movable objects, and they get baked into the texture maps or the Lightmass, the volumetric light maps that we saw earlier. Movable lights are the opposite end of the spectrum. So movable lights are fully dynamic. They can move, they can be animated, the intensity can change. They can interact with objects that are animated in the scene and animated characters and deforming meshes and things like that. So they are 100% dynamic. They are not part of the Lightmass calculation, so they do not add information into the indirect illumination model. So keep that in mind. And they have a cost. Like there's a cost associated with each one of those when it comes to running it in real time. Stationary lights, which is the default that a light comes in at, is sort of a hybrid between the two. So depending on what the light is interacting with, it's going to behave in different ways. If the light is interacting with objects that are not movable, it's going to bake the lighting information into those non-movable objects. And it's going to be part of the Lightmass calculation and part of the indirect illumination model for that component of it. If they're interacting with objects that are movable or are animated, they're going to be treated as though they are dynamic for those objects. So that's cool. They're going to have shadows that cast dynamically and do all the things that you'd expect a movable light to do for the movable object. So again, it's based on what they're interacting with. But they do have some limitations. And the biggest limitation that they have is the fact that you can only have 4 of them interacting or existing within the same volume. So the attenuation radiuses define the volume in which the light lives. You can only have 4 overlapping attenuation radiuses or volumes for stationary lights. So what does that mean? Well, it's pretty easy to understand once you see it in context. So we're just going to drag out some more lights to kind of demo this. So we'll get a spotlight in our scene. It comes in. That's the attenuation volume, that this light lives within, right? So if we change the cone angle, it's going to change the shape of the volume in which that light exists. Obviously, if we increase or decrease the radius, again, it changes the volume in which that light exists. And we just need to make the sky a little bit brighter so that it kind of lights up the scene there. And I'm going to go ahead and just paste in a location to get that light sort of where I want it. So right now what we have is we've got 2 stationary lights in our scene. We've got this guy, it's a stationary light, and we've got this guy. It's a stationary light, and their volumes are overlapping, obviously, because they're within inside each other. So I'm going to hold down my Alt key, and we now have 3 stationary lights. Hold down my Alt key and drag out one more time and duplicate that. We now have basically 4 volumes interacting with each other. So as I said before, you can only have 4 volumes, and once you get a 5th, it's going to have a problem. So let's see what happens when we drag this out. As soon as I drag that out and get a 5th volume, you can see that this light is no longer valid. It's got an X on it. So it's telling me that I've exceeded the number of lights that can exist inside of here. So that means we need to make a choice. We need to either change the shape of the volumes or eliminate, change the type of light from a static to a movable or something like that. And you're going to use different tactics for different situations. For this scene, what we ended up doing is we ended up having several lights that were movable because they don't interact with stationary lights. So you can have, I had like 5 or 6 movable lights, and then most of the lights that were around the stadium, and there was hundreds of them, we just made static. So as soon as we make this light a static light, it's no longer going to be part of that stationary volume. Now, sometimes it doesn't update in the UI right away, and you have to give it a little kick. So I'll show you that in context here. When I switch this to static, you can see that I still have an X on this light, even though I know I only have 4 volumes interacting because I just switched the 5th one to static. So to fix that, all you have to do is grab the light and just give it a little kick. Switch it to movable, switch it back to stationary, and now you can see, it's gone back to no longer having the X. So I've got 1, 2, 3, 4. Those are my 4 lights that are all within the same volume. And you can further visualize this if you want to see where things are overlapping and not overlapping with the stationary light overlap. So by just turning that on, you can see that we've got, all these lights sort of overlapping each other in that region. So that is the basics for how mobility works with lights. And it kind of, it works hand in hand with object mobility to kind of specify what's going to get baked, what's not going to get baked, and what's going to be fully dynamic. So that starts to look pretty cool. So the next thing that we're going to do is we're just going to bake this lighting information into the scene. So we're going to say GPU Lightmass, and I'm going to give it a full bake without the real-time viewport on. And this also has the denser cell volume for the volumetric light map, which is interesting because we have that static light that we had on the right-hand side of the scene here. That static light is actually going to add in information into that volumetric light map, and we're going to be utilizing that volumetric light map to actually work with the fog system actually next. Once it's done writing this out, we'll check that out. So it's going to go through and encode the textures, and just like that, we now have a little bit more bounce light happening through the scene because of those lights that were added in through the baking process. So this is pretty cool. Now, the way we got to that final look for the scene was a lot of glow and some kind of hazy volumetric fog effects happening. And this is super easy to do inside of Unreal. So what we'll do is we'll just search out for fog. We're going to drop in this exponential height fog, and that's going to kind of come in here. And the magic happens when I turn on use volumetric fog. So when we turn on use volumetric fog, you can see we've got a lot of haze in the environment here. So you've got these kind of spotlights pin spotting down here. We've got this other light that's sort of in there too. It's got a little bit of that information happening. And then of course you've got this light. And anytime you're working with these lights, you can go in here and specify how much volume fog is it contributing. You can overdrive it or underdrive it. So I'm going to underdrive the big area light because I really want more of these little kind of pin spots kind of coming down. And of course there's control on the volumetric fog. Lots of control in here. How much fog are you going to use? What color is the fog going to be? How dense is it? So you can use this to really sort of dial in the overall effect and look that you want, which is pretty awesome. So the other thing that we did was we used a lot of glow in that scene. It was really kind of poppy and contrasty with like big blooms happening everywhere. So how do you do that? Well, that's actually easily done with the post-process volume. And the post-process volume inside of Unreal is like, it's just a workhorse. It's super, super cool. So I'm going to drag that post-process volume into our scene. We'll just put it to the origin by clicking the little reset button. And the first thing that we're going to do is we're going to come down to the inherent extend or infinite and extend and tell it to be unbound. So that volume lives everywhere. I didn't have to scale it up. It's just my whole scene is covered with that post-process volume. And now what we're going to do is we're going to kind of come in here and we're going to start to dial in the bloom and the glow on this guy. So let's just kind of float up here like this, look at the ceiling, and let's go ahead and go to the top of this guy and go to bloom. We're going to turn on the standard bloom and we're going to turn on the intensity. And it comes in and it's a little crazy. The default values are not really working with what we have going on in the scene here. So the first thing that I'm going to do is I'm going to come down to the lens flare and I'm going to take that lens flare down to something like 0.08 or something. So it's a little bit less. It's still there, but it's not nearly as intense as it was. And of course, these are artistic choices. Feel free to dial it in however you want. So we got a little bit less lens flare. And the next thing that we're going to do, and this is great, we're going to switch the bloom method from standard to convolution. And as soon as we do that, we get the really nice little flares happening, that little pop happening, and it's a little bright. So we'll go down to the advanced section for this guy, and we're just going to expand this out, and we're going to take that multiply, and we're going to drop that boost down to something like 3 so that we just get this little subtle effect kind of happening with the lens flares and the volumetric fog. And, it just starts to kind of come together. This is really the beginnings of what we did to get where we wanted to be with this guy. And the post-process volume has, it has a ton of different things in here. You could add in chromatic aberration to start to do some weird, kind of digital lens effects and things like that. There's a bunch of exposure controls and film grain controls and tone mapping. It's just an amazing tool, but we don't have time to dive into too much of it today. So I encourage you guys to jump in there and play around with that post-process volume because it's pretty sweet. So that's the beginning of how we did the look development for the scene. So let's go ahead and talk about materials, and we're going to jump over to the actual finished lighting model that was dialed in a bit more with like 100 lights and everything's going to final tweak. Then we'll talk about materials next. All right, so this is what the finished environment ends up looking like after all the look development work. And as I move the camera through here, you get a sense of how all these glows and volumetric fogs all kind of interact with each other. And as you sort of drop down from the rafters of the stadium here, you get this really nice effect. And you can see all that glow underneath the scoreboard and how all those volumetric light shafts sort of interact and layer on top of each other to give you this really kind of nice misty look. And of course, all the GPU baked lighting has been added into the environment, so you get that really good sense of kind of the GI bouncing around. Even though it's a really dark environment, you still get, I think, a pretty good sense of light traversing through the scene and doing some pretty fun things. And this is kind of the look I was trying to go for, was this really kind of bright pops of chrome on a really dark environment with like overblown out bloom and things like that. So I think it came out pretty cool. I'm happy with the end result. The robot that we're currently looking at right now is what the robot materials look like directly imported from Cinema 4D. So these are the base PBR materials with no texture maps assigned to them. So there's really nothing going on here yet. And the way that we actually set the robot up and did the look development for the robot was actually really simple. We just utilized the automotive material pack. So if you haven't used the automotive material pack, I highly recommend checking it out. If you go to the marketplace and search for automotive materials, you can add this to your project, and it's going to give you 164 high quality materials that are all based off of several master materials. So it's got materials, master materials, functions, material instances. It's got everything you need to do anything with hard surfaces. And that's really all we used for the actual robot. So let's go ahead and just check out a few of those materials. So we'll jump into the automotive materials folder. We'll go into materials, and I'm just going to go into exterior, and we're going to grab some of these rubber material instances. So I'm just going to take this basic rubber, and I'm going to drag and drop that rough rubber out onto the limb of this character. And if we double click on this, it's going to open up the material instance. So this material instance is based off of the opaque master. And the opaque master is like a Swiss Army knife material. It just does all kinds of really cool stuff. So you can do anisotropy effects if you did like a brake rotor or something like that. It's obviously optimized for ray tracing, and it has a lot of control in here for dealing whether it's a metal object or not metal object. Anything can be texture mapped. And the main thing that's really driving the overall look of this rough rubber is honestly this roughness map. So if we turn the roughness map off, you'll see that it's actually still got some other layers of imperfections inside of here. And that's just built in further down inside of the material. So you can also do clear coat effects on top of it for like car paints and things like that. And in this example, I'm just going to overdrive that dust value up to something like a value of 1. And you can see that it lays the dust only on the horizontal surfaces. On top of the dust, you can layer fingerprints. I can overdrive that. And then, of course, there's an overall mask file that you can use to contribute how much those imperfections kind of go in here. So it gives you the ability to do, kind of swirls and swirl marks and painted surfaces and all kinds of really kind of fun, cool, interesting layered effects. Now I'm going to go back and just turn back on that roughness map just to get that back in there. And let's go ahead and look at one more material. Let's go and check out something on this character's on the metal. So let's jump back into exterior. Let's go ahead and jump into metal, and I'm going to scroll down here. And I'm going to grab this metal wear too and just drag and drop that on all the chrome surfaces. And let's just kind of push in on this character here. So you can see it's got this really kind of cool, very bright brushed metal effect on top of this guy. And if we double click on that to bring up the material instance, you'll notice that it is also based on that same opaque master. So the masters are super flexible. It's a great learning tool to jump in there and rip that master apart and see how it was put together by the technical artists at Epic. It's a really, really cool material. So what we're going to do for this one is we're going to come in here and we're going to basically just tone down some of these roughness values to get this going back to something that's a little bit more chrome. And that gives this really kind of nice swirly looking effect to that guy. But I wanted to get to something that's a bit more chrome. And you can see that as this kind of moves around here, you're starting to see a couple of seams in this character where that doesn't look like it's flowing across the surface in a very nice way. And the reason that it's doing that is by default, the way these materials are set up is they're set up to use a projection system, because a lot of CAD data that automotive people are working with aren't going to have good UVs. So it has a basic projection system built in to do kind of a triplanar projection on this. But this robot actually had pretty good UVs set up inside of Cinema 4D. So what we're going to do is, instead of using these XYZ projections, we're going to go ahead and just use the object UV. So we'll turn that on, we'll cache that out, and now you can see as soon as I do that, all that information is going to basically flow across the surface of this character, and it has this kind of hammered metal look to it right now, which is kind of cool. And of course, there's a lot of control in here. Like, let's just put this other brushed metal on there just to see what that one looks like. So that's basically the automotive material packs and how they're set up. Really pretty fun. So let's go ahead and close this guy down, and I'm just going to hide this character and pull up the final. And this is what the final guy ended up looking like after we added in a few more materials, did some glass and some glows. And I'm just going to switch over to a camera that's got a little bit of depth of field on it, and we'll just kind of scroll up and down this character just to get a sense of what's going on with this environment. And it's kind of this moody, poppy, glowy, basketball playing robot guy, which I think is kind of fun and kind of cool. So with that, I'm going to pass it over to Andy, and he's going to rip into Cinema 4D and show you guys some really cool concepts and workflows with Unreal and Cinema 4D. So let's check it out.
Thank you so much, Daryl. Today I have the pleasure of walking you through how to build this sports brand logo animation. So if I go ahead and cue this up and play it back, you can see this feels kind of like a big network branded logo coming in, slamming down. And I'm going to walk you through the process of taking this all the way from Adobe Illustrator into Cinema 4D, doing some of the extruding, modeling, basic material setup, and then we'll bring that back into Unreal through our Unreal Datasmith import pipeline. And we'll take a look at the animation, some of the effects elements that I brought in, like the wood floorboards shattering, and we'll put it all together so you can see how to build this for yourself. And then I'll show you some of the elements inside Unreal as far as camera shake and being able to even switch cameras. Okay, let's start off in Illustrator. And I like starting in Illustrator because it produces very good splines that will allow us, as you can see here, to extrude in various forms inside of Cinema 4D. And I tested a lot of different typefaces and shield designs, but ultimately centered around these two. And looking at them, I started to work my way toward this design, which is what I'll take a look at next. I'm going to show you how to prep this file and import it into Cinema. Okay, I copied and pasted the logo into a new document, and I'm going to go ahead and inspect it and make sure that all of my paths come over correctly. So if I go to View and look at Outline, you'll see here that the logo is in good shape. All of these have been converted to outlines. Any kind of effects or fonts, we should go ahead and convert those, and I'm going to show you how. So this word League is still a font, and I need to right-click on it and say Create Outlines. And by doing that, this will come into Cinema 4D exactly how you see, and each one of these will be a path. So the next step is let's export this. I'm going to say Save As. The key thing to know is that you want to change this to Adobe Illustrator 8. And this is a legacy format that's supported by Cinema 4D and other programs that allow us to import the splines exactly as we see them here. So let's go ahead and do that and hop to the next step. So now inside of Cinema 4D, let's import our logo. So we can go Open Project and actually just navigate to your logo. And as you can see, it says set a scale. I'm going to leave it at the 10 centimeters, click OK. You can see that we have all of our splines imported correctly. That's a great first start. Next up, what we want to do is start to extrude this logo back. And so what I'm going to do is I'm going to go ahead and reorganize a little bit of the file so that I can get to this back shield area. And you can see here, what I want to do is extrude this guy back. So we're going to take the extrude generator. I'm going to hold down Alt, and it's going to extrude that back. And this is way too much, so let's scale that down to something like 5. And then also we probably need the bevels on there. And so let's go ahead and bump that up to something like 0.25 and pull this back. So this is closer to something that we would like to see. And we can also go into the shaded or unshaded view, and you can see that this is just too faceted on the side for us. So we need to go into the path and lower the tolerance here on the angle, and you can see that we get much higher resolution. So we need to repeat this process throughout the file. If I go back in and take a look, what I'd like to do is do that, for example, to this Unreal text that's here. So I'm going to go ahead and highlight all of those guys and deselect the star if I can as well. And I'm going to merge this. So I'm going to hit connect and delete. So I have just the Unreal word. I'm going to go ahead and hit extrude, and the same, we're way too extruded. So let's back that down to something like 2. And same for the caps. We need to add a small amount of bevel onto those. And so we would repeat this process all throughout for every spline that we would want to do. And I'm going to jump into the final file and just show you what that process looked like once it's fully done. So here's the final file. I've extruded back many of those. You can see here I've went ahead and labeled some of them, and it's ready for adding materials. And then I went ahead and modeled some mechanical hard bits that would mirror the robots that we had as well. And then I've added a deform modifier to bend all of it into a shield. And so the next step is to, once we've modified all of the geometry and we have it placed how we want, is to go ahead and create some materials. And I did not spend a lot of time on the materials inside of Cinema 4D. You can see in our documentation, we have a list of the kinds of materials that we support and all of the channels that we support. But in my experience, I really enjoy working in the materials inside of Unreal. And so yes, we can bring in some of the bitmaps and the various channels. But what I've done is kept it very simple, and I went ahead and assigned colors, and in the reflectance, I've added some default specularity. Some of these I've added in a chrome material, and I've went ahead and tagged the objects how I'd like them to come in. So I went through each spline here, for example, and added the chrome materials. You'll see that on the extrudes, they actually come in with these selection sets. So we have the opportunity to add multiple materials to, say, the bevels and the caps and all the different things. We keep that once we come into Unreal. So it makes it so you can change those options later. And you can see we've swapped out a lot of the materials for the automotive material pack, and we can do that process through some of our data prep tools as well. So in here, I've went ahead and tagged the appropriate materials. I've prepped the file for export into Unreal. And then I've applied any of the deformers and the symmetry modifiers to be able to bring those in. So next we'll jump into Unreal. We'll show you how to import this file, what we get in terms of the scene, and let's take that next step. Okay, we're back in the Unreal Engine, and we're going to see that we have this Datasmith icon. I'm going to go ahead and click on that and navigate to my file. You can see that we can read the .c4d files. So I'm going to go ahead and click OK. And I'm going to put it in my webinar folder here. Now you'll see we're presented with a dialog box where it'll ask us whether we want to import geometry, materials, lights, cameras, or animations. In this case, I mostly have geometry materials. I didn't really do lights and much in the way of animation, so I'll leave them on. I'm going to go ahead and click OK. And you'll see that we have a pretty good starting place for the scene hierarchy matches what we had inside of Cinema 4D, and all of our materials have been set up for us, and it puts us in a good place to go ahead and import into the scene. Now we can go ahead and take a look at these materials, and if we wanted to customize these, it's a good place to start. We've added the automotive material pack and replaced these materials with some native ones that we are already built, but I want to take a moment to show you what comes in with the C4D file. So if I double click on this, you'll see that we have a C4D master material. And this master material sets up and reflects something similar to what we have. And you can see it's a pretty large and complex material that has many of the same properties that you'll find inside of Cinema 4D. So the color and the metallic and normals and specular. You don't want to edit this, but just to show you where it's at and how these controls are made. So you can turn on any of the properties that you'd like, and which reflects very similar to Cinema on the left-hand side of your physical materials. And so if we wanted to change the color, we could do that, and we don't necessarily have to go back to C4D to make those kind of changes. I'm going to make one change here just to show the process, but if we wanted to, say, take a roughness map and make this material more rough, for example, I'll take one of these roughness maps that we have in here, and you can see this is like a glossy kind of basketball floor material. And so we can add these guys in. I'm going to go ahead and save, and we can see that's already applied to this geometry down below. And if I put this beside and tweak this, you can see that we can change this on the fly and kind of design those materials together. So you can add in the different roughness maps, the specular settings, for example. And we've already done this across the scene, so I don't want to spend a lot of time doing that, but I wanted to show you. It's pretty flexible. If you want to use this as a starting place, go ahead and feel free. If you want to go ahead and replace the materials as well, that's totally up to you. But that's how things are set up by default. Next, we're going to pull this into the overall environment scene with more of the lighting and get into some of the animation. Okay, now that we're back in the main scene, I wanted to show you that a lot of the materials have been upgraded. Daryl did a good job of replacing a lot of those materials and putting in a good wood texture and some of the automotive material pack throughout. And so we've split the scene into multiple levels, and the logo level itself is housing kind of the big logo and the back screens. These back screens are a separate C4D file that I imported just like I showed the logo, and I've taken that Datasmith file here and duplicated that around. So I have 6 of those. And then inside of Sequencer, I've hand animated those. So if I take a look at one of these, you can see that I've animated the position, pretty simple keyframing to be able to kind of cascade that animation on. But I chose to do both the logo and the back screens in the Unreal Engine itself. And then the floorboards was brought in through Mograph. And I'll show you that in this section here. So what's cool is it's brought in as a level sequence, but you can nest a level sequence inside of another. So you can see if I dive in, it says it's a subscene, and you can see all these keys are baked for the different floorboards. So all the animation for that each comes in really nice. It bakes only what it needs. And then inside of this, if I hop out of this subscene and go back up to the top, you can see that we can change that animation. So we can change the whole start point or end point and move that down in time. So I decided to keep those as separate elements so I could control them a little bit better. And that made it really nice for, if I hop back into the main camera angle, the timing of when those could and should hit. The other thing that I love about playing around in Sequencer in this way is once we have everything combined, is we can simply just change the camera angle. So I designed a second angle called camera slam here that's looking up more into the rafters and comes down. And so this might be something going to halftime break, for example, you might see. But it's the same animation, same everything. It's just changing the camera animation. And again, everything is 100% fully live and able to change on the fly. Okay, I wanted to quickly go over the Mograph setup for the board shattering effect that I was using. So it's pretty simple. I have a basic cube that I've cloned 10 times, and then I've offset in the X direction to give some randomness. And with that, I've cloned it again to make a larger pattern. So now I have a large enough surface for the basketball floor. And then I made another random effector, which allows me to move the position in Y here by -80 and add some random rotation in there too, so that when this pushes through, it's going to offset and rotate by that amount. And so you can see that it drives those, as well as I've added a little bit of delay that gives a tiny bit of jiggle in there too, so that it doesn't feel so linear. It's a pretty simple system, but effective. And from this point, the next thing you're going to want to do is make sure when you're exporting Mograph elements, you want to go into the project settings here. If you hit Shift and V, it'll come here into the attribute manager. You can then go into project, Cineware, and you can do this save animation cache, save polygon cache, and this will make sure that it's going to export any of those Mograph clones for you, along with the animation. So I can go save project for Cineware. And then I have this b-ball court shatter that I created. So I'm going to go ahead and import that and show you the result. Okay, let's navigate to the Datasmith button. I'm going to go ahead and click OK, select our basketball court shatter file, and I'm going to go ahead and put that in our existing folder. I'll click OK. And the important part is we want to bring in the animations. So I'm going to go ahead and click import all of those. And you can see it's imported here into the level. I need to reassign some materials, but the cool part is if I go to the animations folder here, double click on it and scrub, you'll see that all those animations have come over and it's baked all those keys correctly. So I'm going to go ahead and select one of these and reassign the materials for it. So let me navigate to where that material is. I have a shatter material that I have set up here. I'm going to go ahead and hit Shift and E, and that will select all the geometry that's similar. So it grabs all the floorboards, and I'm going to go ahead and click the material to reassign it. Now I do remember one more thing is that we're using light channels, and I'm using light channel 0 and 1, and that allows us to isolate the channels of light that it's accepting. So in the example, I think we had this scaled up slightly larger. And you can see here, like when we play through these, all those boards are now shattering and breaking like we had. And if I go back to the main setup that we had, if I open that sequence, go into the logo animation and play this through, you can see here that I can switch this subscene, and I have the new one that's here. I'm going to go ahead and click OK. And you can see those boards are coming in, and so I could realign those just like I would with a video clip. As you can see, this is a powerful way to add animation to your project. And next, let's take a look at camera shake. Unreal Engine offers powerful tools for adding procedural camera shake to already keyframed cameras. So in this example, you can see that I've added some shake onto this, and I want to show you what it looks like when I remove that. So if I right click on the camera here and I mute the camera shake that I've added, you can see it's pretty boring and pretty standard. When the logo hits, definitely needs more weight. And so if I unmute that, you can see here, it makes quite a difference. I'm going to go ahead and show you how to set this up. It's very straightforward. We do it through a blueprint. So if you're familiar with Unreal Engine, we can go to the content browser, create a blueprint, and what we're looking for is something called camera shake. And I'm going to select the one that says camera shake base. And I'm going to go ahead and do this, and I'm just going to call this shake demo. And I'll open this up for you. And we'll see on the left or on the right hand side, we have some different noise patterns here. I'm going to go ahead and click Perlin noise, and you can see here that we have location, rotation, field of view, and some of the timing. When I go ahead and compile this, I'm going to save it. You'll see that this part on the left is not really needed and will go away after the first time I open it. So I've already done this and set this up, so we can take a look at the first example. I've changed the amplitude and the frequency. I've moved these up quite a bit. So I'm at 10, 10, and 15 in the position, and a frequency of 2, 2, and 4. And you can play with these values and see them in real time. So if I go ahead and change that move, and let's say we wanted the roll rotation to be something higher, like 30, we should get quite a bit more kind of side to side movement as we go through that. And I could, dump this way back down to 10, and we'll get a lot less, for example. And so we can design these, save them, and store them, and use them repeatedly. We can change the frequency and keyframe these values to make the kind of camera shake that we want. Once we've done that, I'm going to go ahead and save the asset. And under the camera, all we need to do is add a camera shake track. And you can see here we have the two different ones that I have created in the project, and we can add those in. You can see it also has a nice little fade out showing based on that same menu. So we can design systems where we can add and layer on procedural camera shake, which ends up offering just a much cooler enhancement to the overall animation. Okay, thank you so much for letting me walk you through this process. I'm going to hand it back to Daryl now to walk you through the rest of the promo.
Okay, so the next thing that we're going to be looking at is how we can use Control Rig to animate all the mechanical aspects of the character's joints. So I've got a character on the left that isn't set up correctly with Control Rig, and a character on the right that has Control Rig set up. And you can see, how these knee joints are kind of ripping apart, and all the little mechanical stuff inside of the hips isn't working correctly on this black character. They're basically all kind of ripped apart. And if you look on the red character here, all the joints inside of the hips are behaving correctly. All the rotational values are working exactly the way you'd expect in the way you'd want. So it's a really subtle thing, but it does add this extra level of complexity to all the mechanical little parts and bits of these robots. And that was all set up using Control Rig. So I'm going to give you a kind of high level overview of what it's like to do that type of work inside of Unreal. So what we're going to do is we're going to go over to our skeleton mesh, right click on top of that, and create a new Control Rig to start from a blank setup. And I'm going to walk you through the process of building up a simple little rig to do one of those dampers, and then I'll do a show and tell of the more complex rig for the whole character. So this is the Control Rig window, and it has a pretty standard layout for Unreal. So we've got the original rig here, the original hierarchy of all of the bones. These have a lot of forward kinematics for the primary animation driving those, so rotational values on those bones driving that motion capture data on the character. But all these secondary little bits and pieces like these spinners and these dampers and all those things have not been hooked up, and all of those little pieces of geometry are wired into all these other little bones that we want to ultimately drive with Control Rig. So it's a pretty cool example of how you can use Control Rig in addition to traditional, already animated characters coming in from Cinema 4D to add that extra level of complexity or detail to it. So I'm going to walk you through the process of setting up a really simple control. The first thing we're going to do is create a forward kinematics control for a spine joint. So in the rig hierarchy, I'm going to right click, and I'm going to zoom out so you can see what goes on here. I'm going to right click and say, create a new control. So that new control comes in at the origin. We're going to just translate that up and kind of get it positioned close to this original spine joint right here. And I'm just going to right click on top of that guy and say, set initial transform from closest bone. So it's going to position it and match the rotation to that guy. Now I'm going to go ahead and give this a name. So we'll just call this spine underscore CTRL. So we have our spine control, and I'm going to change the gizmo from that sphere to a circle thick. And then we can take that circle thick and just rotate it around so that it looks a little bit better. So now that we've got that done, the next thing that we want to do is we want to have this control drive that joint. This is really simple to do inside of Unreal. So we're going to go into the hierarchy and we're going to drag the spine out and we're going to say set transform. So the set transform is going to flow off of this forward solve. So a forward solve would be basically things like inverse kinematics, forward kinematics, control systems ultimately driving bones that in return then drag the skinned mesh around. So pretty straightforward. That's what forward solves are all about. So it's going to be the control system driving the bones. So we've got that set bone transform. So let's go ahead and just grab that control and pull that into our graph. And we're going to say get the control. So all we need to do is take the transform from that control handle and have it drive the transform of that bone. So just by hooking those guys up, I've now got a simple control system that will allow me to position that bone. Now, when I spin this, you'll notice that it's moving the spine one, but it's not taking along for the ride the top of the character. And the reason it's doing that is because Propagate the Children hasn't been turned on. So as soon as I turn that on, you can now see that, you know, the rest of the children bones go along for the ride. So pretty straightforward. The next thing that we want to do is we want to build up an IK system for this hand. And then we want to have that IK position the arm, and we want to rig up this little damper in the character's elbow. So let's go ahead and start to create a couple of more controls for the hand. So the first thing that we're going to do is we're going to go up here to that hand L, that bone in our hierarchy. And I'm going to right click on top of that guy and I'm going to say create new control. So by doing that, I've added that control into the actual hierarchy of the skeleton that kind of came in from Cinema 4D. So you can have controls in the skeleton or completely independent. It's your choice on how you're going to approach your rigging. I just did that because it's a fast, easy way of positioning it. So with that done, I'm going to actually go ahead and just unparent it because I really don't want it embedded in that hierarchy. It was just a kind of a shortcut to get it where I wanted it. So we'll just do hand L CTRL. So we've got our hand control, pretty straightforward. Now I know that I need to get another control for the pole vector of the arm. So I'm just going to do a control W on top of that guy. And then we'll just position this out sort of back here behind the elbow, something like that. And I'm going to right click on top of that guy and say, set initial transform from current. So this guy, I hit F2 to rename it, is going to become my pole vector. So let's just put PV and then underscore control. And we'll get rid of the 2 on that guy. So we've got 2 new controls. And we're going to use those to help drive an IK. So let's go ahead and make an IK chain. So we're going to pull off and execute. If you search for IK, you can see there's several different types of IK. We got to keep moving quick. We've run out of time. So I'm going to just do a basic IK. So basic IK is really easy. What it needs is a few bones defined. So we're going to grab the top bone, which is going to be our upper arm L. We're going to grab the next down, which is going to be the lower arm L. And then the end item is going to be, the effector item is going to be hand L. So as soon as we do that, what happens? It basically rips itself apart. And that's like, wow, what's going on? That's not cool. Basically what's happening is this hand is trying to go down and reach the pole vector, the primary effector, but nothing's hooked into the effector. So it's literally just the origin, right? So it's just going down to the origin. So that's not what we want to have happen. And additionally, all the children bones aren't going along for the ride. So similar to that spine joint, we want to turn on propagate the children. So when we do that, it starts to look a little bit better. It's a limb trying to reach the origin. So what we're going to do is we're going to grab both our control vector, our pole vector, and our hand control, and we're going to pull these out and we're going to do a get. So we're going to use those to drive a few of the items in this basic IK. So hand control is going to ultimately go out there and drive the effector. That looks pretty good, but you can see the orientation is still wrong. The pole vector hasn't been defined. So we're going to expand that out and just grab that translate and shove that into the pole vector. So now you can see that we've got everything kind of hooked up here. We start to move our arm. we have a basic little IK system, and I'm actually translating the pole vector as I go because they were both selected, but you get the idea. So now what we want to do is we want to build into this guy the damper. We want the damper to work. So as I start to move this, you can see it's just ripping apart. So this is a really simple little setup or rig. Basically what happens is this little bone right here is going to shoot off and aim at the bone over on this side, and then the bone on the lower arm is going to shoot and aim at the bone on the upper arm. They basically overlap each other. It's a really simple rig. So how do we do that? Well, we're going to do that with aim constraints. So let's go ahead and pull out a aim constraint. So we'll just pull out and type aim. So we're going to use an aim constraint, and we're going to use those dampers. So if we search for damper bone, you can see I've got a lot of them in here. So this is what I was saying. There's a lot of these that you'd have to go through and set up. So we're just going to grab the left damper for, that's the elbow. So we're going to grab the left elbow damper, and then we're going to add to our selection the left end damper, elbow end damper, and we're going to pull both these out, and we're going to do a get transform. So these are going to help us with the aim constraint. These are going to be things that we're going to point to. So what we're going to do is we're going to come up to this aim constraint, and we're going to define what bone we want to run an aim on. So the bone that we want to run an aim on, we'll just search for damper, and we're going to grab left elbow damper. Pretty straightforward. So the left elbow damper, we want to have actually aim at the left elbow end damper. So we're going to grab just the translate of that and shove that into the target. So as soon as we do that, you can see that little bone now is pointing this way and carrying along for the ride. That piece of geometry, very, very straightforward, very simple to do. So we're going to grab this, hit Control W to duplicate it. I'm going to kind of move this guy down the line a little bit. And we're just going to do the flip-flop of this now. So we're going to say, instead of left elbow end damper, this guy right here, we're going to say left damper end, and then we're going to drive it with the left damper. So again, we're going to hook the execute up. Pretty straightforward. You can see it doesn't know where to go, so it's going the wrong direction. But as soon as we drag in this translate for the target, just like that, we've now got it set up and behaving and doing exactly what we want. So hopefully that makes sense. That's just a really quick introduction to how to build things with control rig and get them working. So let's look at a slightly more complex example of actually how we went ahead and handled this character. So, all right, so to finish this off, I'm just going to pull up the red characters rig that we're currently looking at in the viewport and walk you through it. So this is the exact same thing that we just did for the damper, except we're running it through a for loop, because like I said, there's like 14 dampers on here, and it would be really a big rig to do that. So it's actually easier to use a for loop. So the first thing that we're doing is getting a list of all the bones that are called damper. So we go through and we do a simple little difference to get the bones that are just called damper, and we're going to run a for loop on those once we establish that list. After the for loop's going to go through, it's going to take each bone in the list, and it's going to make an aim constraint for it. And it's going to take the first list, the first name, and shove that into the item. And then we need to get the name with the word end on it, that same bone with the word end on it, to become the target. So we're basically going to take the name out, and we're going to add or concat end to the list. So if we just say, watch this value, that's the list of all the end bones. So those end bones, we're going to basically do a get transform. So we're going to basically get the transform for every one of these guys in the list, and we're going to shove it into the target. So really straightforward. Then we're going to come down here and we're going to do the exact opposite. So we're generating a list of all the bones that are called damper end. We're shoving that into a for each loop. And then we're going to cut off the last three letters, cut off the word end to create the bone name without the word end. So it's literally the exact opposite, just like we did in the first example. You need to have one bone point at the other bone and the other bone point back at its matching counterpart across the way. So we're making this new list of names that we're then going to get the transform for each one of those, and we're going to shove that into the target. So it's literally, one bone pointing at the other bone and then the inverse happening on the bottom. And by using this for each loop in just a couple little name filtering things, it's just so much more elegant. And anytime I add another damper into this character, it's going to automatically create the rig for me. It's really, really super, super cool. So the final thing that I want to give you a quick tour of is a completed control rig that has a lot of functionality added into it. So if we double click on this guy, we've got a few things going on. So we've got this forward solve and it's the complete rig. So if I grab this, this guy and start moving him around, you can see that he's completely hooked up and ready to go. So the first thing that we're doing on this forward solve, which kind of branches off here and comes up, is very similar to what we were doing before. So this is just setting up forward kinematics down the spine. So it's getting a transform and setting a bone to that all the way down the spine joints, which is, pretty straightforward. Then we kind of come down here and we run the next series of events, or the next series of nodes that are all the IK systems. So it's building the left arm, the left leg, the right leg. So that's all pretty straightforward. The next thing down is actually kind of fun. So this is how we're handling the hands. And the way the hands are set up is a little bit different. So I'm doing a get bone for the left hand, and I'm getting all the children. Then I'm also basically going through and saying, you know what, give me the right hand. So I'm replacing the name with _L with _R, and I'm joining those two lists together to give me a master list of all the bones from the hands down, left and right. And I run that through a for each loop. I add on to the name of the bone _control, and I get those transforms for that new name, that new list, and I use that to set the rotation of the bones. So I'm basically saying, give me my controls and have those controls now drive those bones. And I'm just using these little naming kind of nodes to help me build that list up. And this is a lot easier than trying to string together, a massive long list of every single finger with all the, kind of joints going down the path of 10 fingers. It would just be, it would be a long list. So using a for loop really helps with that. And then obviously this is the same thing that we saw earlier with the dampers, kind of building the lists and generating those dampers. And then the next thing that we're looking at down here, this is really interesting. So this is the backward solve. So I mentioned there's 3 different modes, right? There's a forward solve. Forward solve, again, is going to be control systems driving bones. So FK, IK, things like that. The backward solve is the inversion of that. It's the opposite. It's the bones that came in from Cinema 4D or wherever being able to drive the control rig. So this allows you to take motion capture data that lives on bones as forward kinematics and bake it onto the high level control rig that then gives you IK systems and other controls to animate that character with. So this is just basically the opposite. It's going to go through and it's doing a lot of get bone and then set control rig to that bone. So it's just a whole bunch of gets and sets, and then some, kind of, this is like a parent offset, like a parent with preserve hierarchy type of thing. But for all practical purposes, it's just a series of gets and sets. Now, this setup is actually pretty similar to the setup that's in the mannequin sample that's on the marketplace. So if you want to play around with it, just grab the mannequin sample and you'll find something pretty similar to this setup. Now, the final thing that is in here is the setup path. And what setup does is it allows you to create an event that's going to be run that will basically take your control system and try to match it into an already existing kind of hierarchy or something like that. So it's going to reposition those controls to match a different hierarchy shape or something like that. So I actually use that to generate the position of all these little hand controls, because that would be a pain to position them all. So again, I just use that parent, all the children down from that, and I'm getting the position of that. I'm grabbing the word control, and I'm basically making that list, and I'm saying, set the controls position to the bones position. And that's what placed all this. So I didn't have to manually place them. So again, it's just a couple little nodes that creates a hierarchy that builds in a little bit of intelligence to your rigging. And the cool thing about all this is if you added extra bones, because we're using all this naming kind of filtering, it would just automatically work and just grab the next bone in the line and kind of do what it needs to do for all these for loops. So that's the basics of control rig. I hope you guys like it. Thanks so much for taking the time to watch this webinar. I know we were going fast through a lot of stuff. They're meant to be kind of high level and touch on many things. If you want to get more in-depth training, make sure you go to our website and check out the online learning section. That's going to be curriculum-based training with source files and much deeper dives in what we're doing in the webinars. So again, thank you to Andy for the amazing Cinema 4D work, and I'll see you all soon.